Hi, I'm Dan Abel, and in this video we'll be drawing electric field lines created by a point charge. Okay, so one thing you'll want to remember for both electrostatics and circuits is that physicists are positive people. And what I mean by that is that everything is defined as what would happen to positive charge. So this means that when we look at which way is the electric field going to point, electric field line points in the direction of a positive test charge. Which way would the positive test charge move? And so, for example, let's say we've got a positive charge and we want to draw the electric field. Well, other positive charges would move away from our main positive charge. So the electric field would point outward because anywhere I put a positive point charge, or what we call a positive test charge that tests the electric field, it's going to move away. So those field lines tell us which way positive charges would move. Now, if I were to put a negative charge in that field, it would go opposite the way the arrows are pointing, and it would go towards my drawn positive charge. Likewise, if my initial charge is negative, and I want to draw the field for a negative, well, any positive test charge is going to move towards my negative charge here. And so that's why electric field lines point towards negative charges, because that's the way a positive charge in that field would move. So physicists are positive people. Everything is defined as the way a positive charge would move. Now, to drive home the second point, this idea of density of field lines telling us the strength of the electric field, we're going to use a problem. So in this problem, we are asked to draw the electric field lines surrounding a +1 Coulomb point charge and a +2 Coulomb point charge, so both positive. And I've stolen the picture from the previous slide where we drew the electric field lines moving away from a positive charge, because that's the way that positive charges would move. And now we want to look at what happens if we double the charge. How do we depict that in the electric field? Well, we do it by drawing twice as many field lines. Now, there's many field lines we could draw, but our pictures are all relative. So if I use 8 field lines for the 1 Coulomb charge, then I should use 16 field lines for the 2 Coulomb charge. And what it means to say that the line density tells us about the strength of the field is if we pick a certain region. Let's say we pick this region I'm going to outline in green here. For the 1 Coulomb charge, there's 3 field lines in that region. But for the 2 Coulomb charge, if I'm careful and I draw roughly the same region, then I'd trap 5 field lines. And if I was really careful, I really should be able to grab 6. There'd be twice as many field lines in that region. It's twice as dense, twice the number of lines show up in that same area of space. And so what that means is if you have twice as many lines, you have twice the electric field, which makes sense because we have twice the charge creating that field. So the big takeaways that you want to walk away with here are that the field lines point in the direction that a positive charge would move, and that the number of field lines in a given area is relative to the size of the charge that created the field, and that means it's relative to the strength of the field at that point.